So, to continue our discussion on recursion, we're going to discuss the two most popular recursive algorithms out there, or two of the most, and that is merge sort and binary search, beginning with the binary search. All right, so the way binary search works, well, before you can use binary search, the array, first and foremost, must be sorted. It must be sorted from least to greatest. All right. If the array is not sorted in that order, binary search will not work. You must use a different algorithm to search on it. All right. Now, that being said, since our array that we're looking at is sorted, we can use binary search. So, suppose that I'm looking for the number 14. All right. Well, the first step is to select the middle value. How does binary search do that? Well, first we must determine the largest index and the smallest index. We'll call the largest index the upper bound, and we'll call the smallest index the lower bound. Add those two together, divide by 2, that'll give you your midpoint. All right, so the midpoint is 3. So binary search says, all right, let's look at the value that's currently at index 3. Is 14 less than, equal to, or greater than the value at index 3? In this case, 14 is less than 32. So that means if 14 is in this list, it'll have to be to the left of index 3. So binary search will now focus its attention on just indexes 0 through 2. So the upper bound now becomes 2. The lower bound stays the same. Add 2 and 0 together, divide by 2, we get 1. So now the value at index 1 is now our midpoint. So is 14 the number we're looking for? Is it less than, equal to, or greater than the number at index 1? In this case, it's equal. So we've found our position. Binary search is done. It'll return 1 as the index of the number that we're looking for. Now, let's try this again on a new array. Here's my array. It has 8 numbers in it, and I'm searching for the number 117. So first step, we need to determine the middle index. Will it be 3? Will it be 4? Well, the upper bound is 7. The lower bound is 0. Add those two together and divide by 2. Keep in mind we're doing integer division, not precise division, but integer division. When you do integer division, 7 divided by 2 will give you 3. So 3 will be the midpoint. Now, I'm going to look at the value at index 3 and ask, is 117 less than, equal to, or greater than the number at index 3? 117 is greater than 44, so that means if 117 is in this list, it'll have to be to the right of index 3. Right? So now binary search will focus its attention on indexes 4 through 7. Now we need to determine the new midpoint. The upper bound stays the same. The lower bound is now 4. So the midpoint becomes 7 plus 4 divided by 2. That equals 5. So 5 is our new midpoint. So is 117 less than, equal to, or greater than the number at index 5? 117 is greater than that number. So that means if 117 is in this list, it'll have to be to the right of index 5. So now we have an array of size 2. Our upper bound remains the same, but the lower bound is now 6. Add 7 and 6 together, divide by 2, you get 6. So now 6 is the new midpoint. Is 117 less than, equal to, or greater than the value at index 6? It's greater, so that means if it's in the list, it'll have to be to the right of index 6. Binary search repeats again. The upper bound is 7, lower bound is 7 as well. Add those two together, divide by 2. Obviously, we get 7. So now 7 is the new index. Is 117 less than, equal to, or greater than the value at index 7? It's equal to. So in this instance, binary search will return 7 as the index of the number that we're searching for. Now, merge sort. Merge sort is an algorithm whose job is, as the name implies, its job is to sort an unsorted array. And merge sort does this by breaking the array down as much as possible into individual parts. It repeatedly divides the array in half until you have just a bunch of individual numbers. Once broken down, it starts merging it back up. It starts building it back up by merging them together. Here's what I mean by that. So first step, how we need to determine how are we going to split the array up. We need to determine the midpoint like we did with binary search. So the upper bound is 7, the lower bound is 0. Add that together, divide by 2, we get 3 as our midpoint. So that means 0 to 3 will form 1/2 of the array, and 4 through 7 will form the other half. All right, so merge sort breaks this algorithm up in half. Then we'll do the same thing on these two subarrays, okay? But let's just focus on the left subarray for now. We'll focus on the left side. Once we've completed the left side, we'll go back and do the same to the right side. So on the left side, we break it up again. Then on the left side of these two subarrays, we break it down. For now, so now for this subproblem, on the far left, we've reached the base case where we have an array of size 1. That's the base case for merge sort. So now that we've reached the base case, we're going to start merging values together. So, and we do that by comparing 27 and 48. Which number is smaller? 27 is smaller, so 27 gets brought up first. And since 48 is all that's left, 48 gets brought up afterwards. Next, we break down this subarray into two parts. Now they're at the base case, and now we can merge it back together. 13 and 49, 13 is the smaller of the two, so 13 gets merged in first, followed by 49. Now we have two sorted subarrays. They're both sorted, so now we can merge these subarrays back together by comparing the first values, the first items in those two subarrays. So 13 and 27, 13 is the smaller of the two, so 13 gets brought up first. Next, compare 27 and 49. 27 is the smaller of the two, so 27 gets brought up. Next, 48 and 49. 48 is the smaller of the two, so 48 gets brought up. 49 is all that's left, so now 49 gets brought up. All right, so now the left side of this problem is now completely sorted. Now let's sort the right side. Break it down, break it down. We're at the base case, so we compare 7 and 42. 7 is the smaller of the two numbers, so 7 gets brought up, followed by 42. Now on the far right, break it down. We're at the base case. Let's compare 38, 54. 38 is the smaller of the two. Bring 38 up, followed by 54. Now our two subarrays, they're now sorted, so we can merge them. So let's do that. Let's compare. 7, 38. The smaller of the two is 7, so 7 gets brought up first. Next, 38 and 42. 38 is the smaller of the two, so 38 gets brought up next. Next, 42 and 54. 42 is the smaller of the two, so 42 gets brought up. 54 is all that's left, so 54 gets brought up. So now the left side and the right side are both now sorted. So now we're going to merge these two sides together to create one completely sorted array. All right, starting with 13 and 7. 7 is the smaller of the two. Bring it up. Now we got 13 and 38. 13 is the smaller of the two, so we bring it up. Followed by 27 and 38. 27 is the smaller of the two. Raise it up. Next, 38 and 48. 38 is the smaller of the two. 38 gets brought up. Now we got 48 and 42. 42 is the smaller of the two. 42 gets brought up. Next we got 48 and 54. 48 is smaller. 48 gets brought up. Then we got 49 and 54. 49 gets brought up. 54 is all we have left. So 54 gets brought up.